Hi, I am Likhit from Team 0 and 1. In this video, we will be presenting our work and visualizations done as part of third assignment. I will start the presentation by explaining a few pre-processings done to the dataset which make it easy to make visualizations and train models, that is the visual analytics workflow. The pre-processing kicks off by merging the datasets of 2020 of the years 2020, 2021 and 2022. This is done to increase the span of the visualizations. The second step in the pre-processing involves filling the null values with NaN. So basically, initially the dataset has many null values. To wherever the null values are there, we have replaced it with a constant term NaN because initially there were it was with hyphens or question marks. So basically, we have replaced everything and filled with NaN. Then we have replaced all the special characters with empty string. For example, in columns related to money like annual salary or gross pay, they were prefixed with dollars. So basically, we have replaced all of them with empty strings and converted them to their respective types. Like for salary related terms, we have converted to float, and elected official, which is a Boolean term, like to say whether if an employee is elected or not, we have converted it into integer. With that, the third step in pre-processing includes label encoding. Though label encoding is not used here to generate inferences, it will be used later in the visual analytics workflow to apply models on them, because models doesn't accept categorical features. So basically, we have selected the features that are categorical, which are department, job title, sex, ethnicity, and pay status, and replace it with a label, with a numerical label. For that, we have used the label encoder object. We have used the label encoder, which creates an object and fits and transforms at the same time a column. So basically, fitting assigns a label to every category in the column and transform the respective column. We have also stored this department mapping, which will be used later. With label encoding being done, we have included a column experience years, which calculates the experience of an employee based on his status. Like if the employee is terminated, the experience will be the difference number of years he has worked, where the final date is given by the date terminated. But if the case is that he's not yet terminated, if he is active, then we have taken the current year, assuming that he is not terminated till date. So with this pre-processing done, we have our data set in this way. With the pre-processing done, I will hop on to a set of visualizations that inferred insightful information. Later, one of these informations are chosen to incorporate into the visual analytics workflow. The first inference is the trends in termination. I will not go in detail to this because Samarth will be explaining this in more detail. I'll just make it brief on the graph. Here the red plots show the employees that are terminated, and blue plots show the employees that are active. We can observe that terminated people are having low pay, and Samarth will explain this in great detail. Then I have plotted these trends in recruitment. So basically, the idea behind plotting this is to observe how the recruitment has been carried out over years. It is obvious that it will be increasing due to the rising demand, but there is a sudden increase in the latter half of the previous decade. I would infer this is because of the sudden uprise in AI, artificial intelligence, because it required a different set of employees than who are at present. Like we can that I hope that is the reason to elimination here. Like you can see, this is very denser here. So basically, because of this artificial intelligence, people with less skills have been eliminated, and people with higher skills have been taken into the employment. Then I have limited my visualizations to single department without loss of generality to get better results and meaningful information. So I have taken sheriff department for that, and for this exclusive to this visualization, I have eliminated all the pre-processing. This doesn't this have nothing to do with the pre-processings. It does its own pre-processing. So basically, I have taken all the data sets starting from 2016 to 2023 individually, and extracted the column of sheriff department, extracted the rows of sheriff department, and added the gross pays of their employees, and named it as annual budget. Like consider it as the annual budget. I have plotted this annual budget. We can observe that annual budget was increasing till 2018, and there was sudden drop till to 2020. And there is a sudden uprise from 2021 to 2022. Though I am not able to get better inference here, like due to the limited data set of just 7 years, I can observe, I can link this sudden uprise of sudden uprise in 2022 to 2020 to 2022 to this sudden recruitment. These two are interlinked because since there is a heavy recruitment, the department needs budget. Note that sheriff department was chosen because it without loss of generality. Then I have still narrowed down this visualization to a single job role in the sheriff department, that is a deputy sheriff. The idea behind this is to still narrow down and make meaningful thing. This visualization is basically shows a relation between the experience and gross salary. So basically, if you limit the visualization to a single department and single role, the only factor that the only factors that affect your salary is your experience and skill set. So basically, I have plotted the same x-axis as the experience and y-axis as the gross salary. This red line shows the variance of average gross salary across the experiences. We can observe this is linearly dependent till around 6 to 7 years of experience, but then it achieved a saturated state. Like as the experience, though the experience is increasing, the average salary is the same to an employee. Then I will also have a little inference on this skill set. So basically, skill set can be explained in this way. If you take a line parallel to y-axis, it includes all the employees with same set of experience, but a varying set of salaries. The varying factor here can only be the skill. So basically, this like what inference I got here is for people of less experience, the skill they are all are having closer skills, which can be explained by the dense scatters. Since all are being paid all in the same amount, we can say that all are having same skill set. But as the experience increases, the scatter plots were farther apart, which says that employees are having varying skills, like they some are with better skills or some are with lower skills. So with this, I will rest my part and let Samarth continue by explaining the termination trends, followed by the visualization chosen to use in the diamond workflow, which embarks on this deputy sheriff department. Thank you.
Yeah, so hi, I'm Samar. I'm going to start with my presentation. So yeah, so this is the pre-processing part. How we did changes to the initial data set and how we merged the multiple data sets of the years 2020, 2021 and 2022. I think this is already explained by Likith. I'll directly go to the first plot. Yeah, so this is the first plot to where we analyze the terminated employees in the entire county. This is one of the important visualizations of what we have done. Basically, basically we plotted the graph between gross pay and the date of joining of the employees, and we can clearly see that all the terminated employees or most of them have the gross pay less than 50,000, which means that they are trying to remove. Terminate those employees whose annual gross pay is very less. Yeah, so this is one of the inference on of what we got. And also in the year around the year 2020, we can see that there are so many employees got removed when compared to the previous years. This may be due to COVID-19 or some other case. Yeah, so coming to the main task on which we are going to perform the feedback loop. So yeah, so this is the plot. This is the plot between gross pay and tenure for a particular department, which is the sheriff department, and a selected job profile, which is deputy sheriff. So uh, in this plot, we can clearly see that there is some kind of relationship between gross pay and tenure in this shape. So if we consider an ML task where we want to predict the gross pay based on this tenure attribute, we'll just run a linear regression model for simplicity. We get a root mean squared error on the test data, which is 23,176. For the test data test size, we took 0.1 per basically 10% of the total data set size. On this, we got a loss of 23,176. So now if we consider this data visualization, which is shown here, we can see that there might be some kind of quadratic relationship between gross pay and tenure. So basically, maybe gross pay is dependent on tenure square also. So if we if we try to include this inference in our model, so to include this, what we'll do is yeah, so basically here we can in this code, in this part of code, along with tenure, we are also creating a new column which is tenure 2, which indicates the square of the value of the tenure. So we'll include this value in the original data set. This is basically doing a performing a feedback loop on this analysis. So in this new data set df new 2 will have tenure and tenure square also. So now on this we can run a linear regression model. Basically in this regression linear regression model will not only have tenure but will also have tenure square. So so we have multiple variables here. Uh, and if we do the loss which is basically root mean squared error, we get 18,277. So we can see a significant amount of the reduction in loss value. So yeah, so this is the plot for the plot between actual gross pay and predicted gross pay. uh, this is for degree 2, that means we included both tenure square and tenure values. This is the actual versus predicted gross pay when we include only the tenure attribute in the data set. So here we can see a non-linear trend between predicted gross pay and actual gross pay. Uh, Actually, we know that predicted gross pay is linearly related to the tenure, which is our assumption in the linear regression model. So and seeing this non-linear trend, we can also say that predicted gross actual gross pay is not linearly dependent on tenure. Uh, now the same thing happens here. Even in here, the non-linear trend exists, but it is far better than the previous one. Here we can clearly see that there is some kind of quadratic relationship between tenure and gross pay. But here, if we use the quadratic relationship between tenure and gross pay, we even then there is a non-linear trend, but it is way better than the previous one. So now so basically we can tell that loss is reduced. So using this data visualization, we reduce the loss. Uh, so we increase the model performance also. So now, but we cannot tell that the gross pay is quadratically related to tenure. So now we'll try to plot for multiple degrees of tenures, 3, 4, 5, and see how these varied depending on the degree of tenure. This is for degree 3. So that which means that we also included the tenure cube attribute in the dataset, and this is for degree 4, which means we also included tenure power 4 in the dataset. Uh, Here we can see that the loss, yeah. Uh, so yeah, this analysis part will be continued by Pawan.
Hi, my name is Pavan, and now I'll talk about the visual analytics pipeline which we have used with respect to our task. So, in our task, we want to predict the gross salary of an employee belonging to a particular job profile of a particular department using only their tenure. Now our original data is tenure, and then we want to build a linear regression model using which we want to predict the gross salary of the employee. Then after that, we visualize this model only to find a nonlinear relationship between actual gross pay and predicted gross pay using linear regression. Then we infer the knowledge that there is a non-linear relationship between tenure itself and the actual gross pay. So we go back to data, we transform the data, that is we also use tenure square in addition to tenure in order to predict gross pay. So we build a linear regression model again here, and then again we visualize the plot between actual gross pay and predicted gross pay, only to find that there is a non-linear relationship between them. Using this, we infer that there might be higher order degrees of tenure being used in order to predict the gross pay. So we keep doing this for higher degrees of, we keep repeating the loop for higher degrees of tenure. Now, for all the degrees of tenure, we see that there is a non-linear relationship between actual and predicted gross pays. This suggests that maybe any degree of tenure is not completely sufficient to determine the gross pay. Using this thing, we simply hypothesize that there might be some exponential relationship between tenure and gross pay. This is being set in context of Taylor series, where e power x is expressed as sum of higher order degrees of x. Then similarly, we feel that gross salary can be expressed as a sum of higher order terms of tenure as well, degrees of tenure as well. So we have two facts to support us in this. So this is the relationship between loss and degree of tenure attribute. We see that as the degree of the tenure attribute increases, the loss function, loss value decreases, and after which it increases. This gives us some confidence about convergence with respect to exponential nature of tenure with gross pay. This is because the higher order degrees simply overfit the data. That is why the loss simply increased. The degree 4 was the sweet spot, and this suggests that there is less but non-zero contribution of higher degrees of tenure towards determining gross pay. This is a necessary condition for exponential relationship to exist. This again comes from the Taylor series. Second fact is we can visually see the exponential relationship between tenure and gross pay. So this is like an exponential relationship, which is actual exponential relationship should be like this, but then this is reflected and so on, reflected and translated. And please note that whenever I use exponential relationship between x and y, we assume that y is equal to a plus b e power cx. So a, b, c could be negative and so on. And all this analysis seems to be true in context of many organizations. Initially, when the employees start their job, their salaries are initially low, and over the next few years, as they keep working, their in the initial years, their increase in salary is much more as compared to their increase in salary towards the last years of their working. So this was our analysis. This is how we did our visual analytics pipeline and the corresponding analysis. Thank you.